brackets, which is perfect. All right, so this is unit 2A, right? Intro to functions. We are on day, what are we on? Day 9? Day 9, and this is just more piecewise functions. And there's a special function out there. It's called the greatest integer function, and it can be defined as a piecewise function. So the greatest integer function, kind of a mouthful. And if you see y equals with this weird either brackets like that or a double bracket with an x in it, that's what the greatest integer function is. All right. So the definition of the greatest integer function, if we want to say f of x is equal to, and here's the little squiggly bracket for piecewise. It's going to be equal to plain old x, right? There's the x inside. Y equals x, right? It's going to be equal to that. Now, here's the if, and this is the big if, right? For what x values? If x is an integer, right? So if x is 5, if x is 10, if x is 1, if x is 0, -1, -10, right? All those nice counting numbers, positive, negative, and 0. All right, but if, and I'm going to leave a bunch of room here, if x is not an integer, right? If x is a half, if x is pi, anything that's not an integer, here's where the greatest integer function gets its name. Y, f of x, is going to be equal to the greatest integer less than x. And that's why it's called the greatest integer function. So this right here is the super important part. And this function doesn't come up all the time, but it is an example of a piecewise function. So we could talk about it on the day after we had talked about piecewise functions. All right, so let's try and get an idea of what's going on here. So if I make a t-shirt, right, with x's and y's, and over here, I've got my all right, so we go ahead and let's plug in some integers, right? Let's go ahead and plug in 0. What pops out? 0, because y is equal to x. So at 0, 0, I've got a point. At 1, 1 is an integer, right? What pops out? Plug in a 1, pops out a 1. So at 1, 1, so you can start to see that line y equals x, right? But don't connect the dots. Plug in a 2 pops out. Plug in a -1, a -1. Plug in a -2, right? So we've got all these closed circles, right? We are equal to x. All right, now what happens? What if we start plugging in values that are not integers, right? So what if I plug in 0.5? Here's what y is equal to. F of xy is equal to the greatest integer less than 0.5. What's the biggest integer less than 0.5? 0. So a 0 pops out. That's what makes this thing kind of weird. So when I'm at 0.5, a 0 pops out. What about when I'm at 0.7? Greatest integer less than 0.7? 0. What about 0.9? 0. What about 0.9999999? 0, right? Greatest integer less than. So am I going to keep going on this line right here? I'm going to keep going, keep going, keep going. Am I getting closer and closer to 1, right? But what happens at 1? We jump up here. So what's going to happen at the x value at 1? I'm going to put an open circle right there because I'm getting closer and closer and closer, but I'm not touching 1, 0. What happens if I plug in 1.1, 1.2, 1.3, 1.9? What are the y values for all of those x values? 1, right? Greatest integer less than 1.1, 1.2. So am I going to keep going at 1? I'm going to keep going, keep going, keep going. Open circle at 2, 1. As soon as I hit 2, it jumps up to 2. So can we start to see the pattern there? All right, what happens if I plug in, by the way, these were all 1, right? What happens if I plug in negative 0.5? And we got to be a little careful here, right? Negative 0.5. What is the greatest integer less than negative 0.5? Negative 1, right? Less than negative 0.5. So here's negative 0.5. What's the greatest integer less than? Negative 1. So isn't this guy going to be right there? Aren't we going to continue that pattern? Open circle. So now, once you see the pattern, is this also called, right? Could you do this with an open circle, right? Dot, line, open circle. Could you keep going with that pattern? Dot, 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 et cetera, et cetera. Is another kind of like unofficial name for this called the step function. It looks like a bunch of steps. Looks like a bunch of steps. So can the greatest integer function be defined as a piecewise function? Yeah. Is it always defined as a piecewise function? No. But since we're doing piecewise, made sense. All right, now take a look. Graphing calculator. On your graphing calculator, you can graph the greatest integer function, which is no, not a GIF. When they decided greatest integer function, there were no such thing as GIFs. So not that acronym. But take a look. If you go to y equals, and you want to plug in the greatest integer function, you go to math. Then you arrow over to number. And see number 5, int. You hit that. That int right there is going to give you the greatest integer function. So if we plug in an x, and if we zoom, I don't know, zoom 6, it's giving you all those steps. Now, is it hard to see if it's an open or closed circle? Right? That's tricky to see. On the home screen, if we second quit, if you want to go math, number, right? Number 5, integer. And if you wanted to plug in, let's say, what did we do? Negative 0.5 here. And you plug in negative 0.5, enter. It'll give you, trying to see the best way for you to see that. It'll give you that negative 1.
Wait, how did you get the
Same thing, math, number, 0.5. So on the home screen, you could have evaluated, right? You could have used the chart there. Or if we're on the graph, could you hit trace? And what if I wanted to trace negative 0.5? Enter. It'll also give you the x and y value at the bottom there. So you can trace any one you want. What if we wanted to trace 0.7? Want to trace 0.7? It gives us that 0. What if we wanted to trace 1.99999? What should the answer be? 1, right? And it gives us the 1. So one more function that we could define as a piecewise function And that sort of sums up our piecewise units or lessons.